great turnout for our heat pump workshop. My name is Paul Cameron, and I'm the Executive Director of Brattleboro Climate Protection, which is a nonprofit organization that works closely with the town of Brattleboro and the community to promote energy efficiency, renewable energy, and transportation solutions. And I want to start by thanking our sponsors, which include the Brattleboro Energy Committee. We have a couple members of that committee here tonight. Efficiency Vermont, the Marlboro College Graduate School, and I want to thank especially VCTV for taping tonight's talk for broadcast. Also, there will be time after the main program to visit the exhibitors in the room next door. We have several great exhibitors, including Sweeney, Rogers, and Garrity, which distribute Fujitsu heat pumps, HB Energy Solutions, ARC Mechanicals, Vermonmt Power, and VSECU, and Home Energy Advocates. So after the main program, I hope you'll take time to go talk with those folks and ask questions and learn more about their products. So before we get started, I'm just going to quickly go through the agenda. We're going to start with a keynote Sargent Efficiency Vermont, which should take about an hour. Then we'll have a testimonial from a local homeowner who has purchased and installed a heat pump water heater, and he'll talk about his experience with that. Then we have two people from Green Mountain Power who will talk about GMP's heat pump leasing program, and then a person from the Vermont State Employees Credit Union, or VSECU, to talk about other financing options for heat pumps. And then we'll have a question and answer session at the end. So I'm going to start with our keynote presenter, who has come down from Burlington all the way from Burlington tonight to speak to us. Matt is the Senior Energy Consultant with Efficiency Vermont. So I'll turn it over to Matt.
Hi, I'm Matt. We're going to talk about heat pumps tonight, and hopefully by the time I'm done with my little workshop presentation thing, what I'm hoping for is that people go home with some sort of sense about, okay, I think I know what it is, I think I know some things about it, and I have a better sense of whether or not this is a good thing for me to pursue. Because we're at Efficiency Vermont, we try to partner ourselves with everybody as your trusted energy advisor. We're not selling heat pumps. We're not distributing heat pumps. We're not recommending any specific heat pumps or any specific vendors. We just want you to know that this technology's out there. Here's what it is. There's some things you need to know about it. That kind of stuff. So let's go ahead and get started. Here's what we're going to do today. We're going to talk basically a little bit about the technology. We're going to go through the economics, what makes a successful installation, and what kind of program support is out there for you if you're looking to move forward at that point. So, what are the benefits? We get heating and cooling from the same piece of equipment. So, it works a refrigerant cycle, and you can run that cycle in reverse to do air conditioning, or run it forward to do heating. So it's the same piece of thing. You can use it summer and winter. It's really efficient at both of those things. So we're talking about, in some cases, double the efficiency of a standard air conditioner when it's in cooling mode. That kind of thing. Very, very highly efficient stuff. For an existing home application, you can put it in pretty painlessly. It doesn't need a big demolition. It goes in pretty quick. There's a line set to run between the inner and the outer unit, and drill a couple holes for that, and we're in. And I'll get into more about what makes a good installation in a little bit. In new construction, where we have control over how we build the building, we can sometimes get the loads low enough that these things can do most of the work for heating and cooling, providing a great deal of savings there. And totally sustainable if you have a renewable energy system, right? You can use that to power this. You're heating and cooling right from your PV panels. So that works out pretty nice. All right, what are we talking about? It's an air conditioner, basically. Think about an air conditioner running backwards in reverse, so that we're taking heat from outside and we're moving it inside. Let's start thinking about that concept a little more. So we start with the heat source, and we move the heat over to what we're calling the heat sink. So this photo here, I'll figure this thing out, is showing the heat source over here. It could be air, it could be the ground. You've heard of a ground source heat pump. It could be the water, as if it were a water heat source heat pump. And then here, we're using the building for the heat sink. So we're using the space heat in the building as a place to put the heat. Here's another schematic for you. This is more representative of the, we'll get into more into the terminology, but of the classic mini-split, ductless mini-split heat pump. We've got an outdoor unit. The refrigerant comes through here. It goes through the compressor, not the repressor. It comes in here and it goes to the indoor unit, indoor coil, and dumps off some heat inside. Goes back out, absorbs some heat, gets compressed, moves inside, evaporates, dumps the heat off. That's what the outdoor units look like. You can see this one's up on a stand. It's up out of the snow, which is good. I like to see them with a little coverage over the top so they don't build up snow and ice on them. But this one's in pretty close to the building. Here's the electric wire that runs it, and here's the refrigerant lines, these black lines here coming off the back. And that's really all there is to it. You are going to see it. You're going to see it on the outside of your house. It's not like some invisible thing like insulation that you can't see. All right, where are we? Okay, let's talk about ground source heat pumps. That was an air source heat pump. This is a ground source schematic. So we can see we have a bunch of tubing loops in the ground, and we run some fluid through these. They absorb some heat from the ground. They come up here, we pump the heat out of it, dump it inside, and it cools off the fluid. The cold fluid goes back in the ground, gets warmed up again, and works that cycle. Here's what it looks like in real life. It's a trench with some tubing in the ground, typically 6 or 8 feet deep. Miles and miles of tubing outside. We can see a picture of the inside box there. That's what the inner piece looks like. Ground sourced heat pump. And then another type is water. So here we've got a schematic of an aquifer, and we're pulling some water out of the aquifer, extracting some heat from it, and dumping it back into the aquifer. Water sourced heat pump. And that's what water looks like. Sort of. I never understood, like, what's that bucket hanging on? It looks like it's hanging on the water. Anyway. I digress.
Hard water.
Hard water. Maybe it's frozen water, I could tell. Okay, so now let's talk about the heat sink. And in this case, we're talking about space heat. Okay, we're going inside with the heat. We're taking the heat from outside, moving it inside. And in this case, it's sort of schematic version of a mini split heat pump where the indoor unit up here on the wall is delivering its heat to the, okay, I don't like this. Next slide. This is another way to deliver the heat. So this would be air to water heat pump. Now, this is showing like a low temperature radiant floor. So if we can take the heat from outside and we can put it into water, now we can pump it all through our house and tie it into the existing heating system, or in this case, into a radiant system. There's some really exciting new technology that we should be keeping our eyes on coming out in a year or two. There's actually already stuff out there, but it's kind of a limited palette of products to pick from. I've seen people doing this, it works, but there isn't really a great deal of selection out there now. I'm really excited about this because this is going to blow it wide open. What I'm going to talk about mostly today is air-to-air heat pumps. So the heat sink is air, the heat source is air. Mostly we'll talk about ductless mini-split heat pumps. I'll get more into the terminology later. But this is a different style, really worth keeping our eyes on. Talk more about that later. Here's another heat sink, right? Domestic hot water. So in this case, the way a heat pump water heater works is it's got the heat pump up top and the water tank down here, and it pumps heat from the air and puts it into the water. It's a little bit of a parasitic load in that it extracts heat from your house, puts it into the hot water. I guess someone's going to do a bit on domestic hot water. Great. So like I said, air to water, much higher efficiency than we're seeing with standard electric water heater. I'm going to get into terminology more, but like COP, coefficient of performance, if a standard electric water heater is at about 92% efficient, it would have a COP of 0.92. Domestic heat pump water heaters are looking at COPs of like 2.3, 2.5, 2.75, so 250% efficient versus 92% efficient. So there's some great savings to be had. Efficiency Vermont has a discount available on this equipment. Here's something I just learned a couple months ago, but the new federal standard for electric water heating, if you go to the store and buy a new electric water heater that's 55 gallons or more, it's got to be one of these. So we're not doing any more of the big Mongo 80 or 120 gallon electric water heaters. They're all heat pump water heaters now. Here's some considerations. So like I said, it takes the heat from the air in the room and extracts it and puts it into the water. And the byproduct of that is cold air coming off the backside of the heat pump. So it can cool down a space. If you put it in a small closet, it can take all the heat out of that closet pretty quickly. And if you don't have some connection to the warm air in the rest of the house in that closet, we're going to cool that closet right down. So it makes sense to think about where we're putting this. They work great right next to your existing heating system in the utility room. They can just take all the waste heat off of that. Again, we're looking for a place about 10 by 10. If you put it in the basement and there is some other heat source down there, it should work pretty well with that. And one of the really nice benefits is dehumidification. So cool, dry air coming off the backside of the heat pump on this thing. And if you're running a dehumidifier, I'm not saying this is going to happen in every case. I've seen a lot of different data from a lot of different houses, and in some cases, you can replace your dehumidifier with this. So basically using about the same amount of energy just to heat your water, and you get free dehumidification. In some cases where they don't use that much hot water, it's not doing that much dehumidification because it doesn't run that much. So every house is going to be different. Every installation is going to be a little different. They do require a condensate drain. Sometimes we need to use a condensate pump to lift the condensate water and get it into a drain. And they also make a little noise, right? It's got a heat pump in it, which is a pump, which is a machine that goes, something like that. And it makes a little noise. So if you're going to put it in the master bedroom closet, rethink that strategy. Okay. Enough said. Let's look at space heat. Okay, so the overarching term is heat pump. So there's heat pump water heaters, there's ground source heat pumps, there's air source. They're all heat pumps. Your refrigerator is a heat pump, right? It pumps heat from inside the refrigerator box and puts it in your kitchen or wherever the refrigerator is. Your window air conditioner is a heat pump. It's pumping heat from inside the house and putting it outside the house. So opposite of what our heat pumps are doing, but they're all pumping heat. They're all moving heat from here to there. It's an overarching term. We're going to talk a lot tonight about ductless mini-split heat pumps, right? So no ducts. There's no distribution system. It's a box on the wall, has a little fan in it, and it moves air out into the house. Connected to an outdoor unit, and that's where mini-split term comes in. So a split system has an outdoor unit and an indoor unit. A multi-split can have one outdoor unit and several indoor units, 2 or 3 or 4 sometimes indoor units. And those indoor units can all work a little differently. There are flush-mounted ceiling cassettes that can be recessed up into the ceiling that distribute air out from the middle of the room. There are, the typical ones we're going to talk about tonight are the wall-mounted indoor units, but there are also ducted systems where you can tie it into a small duct system and pump hot air from the room. It's a multi-split, has a bunch of different things you can do with it. Let's talk about efficiency. So all these terms, we're talking about BTUs per watt. So how much heat can you get out of it, or how much energy do you put into it? So the HSPF is the seasonal heating efficiency of the thing. So all season long, you're going to be heating with this thing, and it's going to start up and shut down, and it's going to run, and it's going to stop, and it's going to do all this cycling, and its efficiencies are going to bounce all over the place for all the different parts of its cycle. But at the end of the year, how did we do? What was our average efficiency at the end of the year? That's the HSPF. Now the SEER is like the same thing for the cooling season. So at the end of the season, what's the average efficiency that this appliance ran at? And the year is a good thing to know if you're on an electric utility and you're putting a lot of these things on your grid. Because this tells you how the thing works at peak cooling. So when it's 95 degrees out and this thing is working as hard as it can work, what's the efficiency of it? And you want to know that because if you have several thousand of them in Brattleboro, for instance, what's going to happen on that July day when it's 95 degrees out and all these things are cranking? Your peak load is going to go way up if you don't have efficient systems out there with a good EER rating. So we want to know how it does when it's really stressed, and that's the ER. So 3 things to watch out for. Again, we talked about the concept of moving heat. These don't generate heat. It's not, we don't burn anything. We don't, there's no combustion. There's no magic like rodent on a wheel inside, like doing anything fancy. It's just a refrigerant cycle, and it's just moving heat from here to there. A high HSPF is good for heating. COPs, remember we talked about that, coefficient of performance in the 2 to 4 range. Okay, what's a COP? I mentioned this before, it's energy out divided by energy in. It's the output over the input. And we use this because it gives us a way to compare, like I did before with the electric water heater. So if we want to compare this against a boiler, let's say we have an oil boiler that's 85% efficient. And we want to talk about efficiency of heating. We need to use a number that sort of matches that. So we use a COP. So that means like 200 to 400% efficient. Right? Is everybody glazing over? 400% efficient, I'm like talking Greek, right? It doesn't work. Here's how we do that. So we start with a heat pump. Here's the machine. We have a source. In this case, let's say our source is air, the outdoor air. We put some electricity in, right? That's our input energy. We put 1 kilowatt hour of electricity in. We pump, and we get 3 kilowatt hours of heat. That moved from outside to inside. So it takes 1 unit of energy to move 3 units of energy. That gives us a COP of 3 over 1 over 3. Right? That's how we do it. It's not like some shell game or anything. It just takes a little bit of energy to move the energy, and that's where we get our efficiency. How we doing? Everybody got that part? Everybody can still hear? Still awake? It's Monday. So when we're talking about putting these things in Vermont, we want to make sure they're going to work in really cold temperatures. And we want to make sure they have some sort of reasonable efficiency when it gets cold out. These didn't used to work well in cold temperatures. And I remember saying to people, I've been doing an energy consulting job for a long time, and I've specifically remember saying to people, oh, no, that's not for Vermont. We can't use that here, it doesn't work, right? And then eventually technology got better and I had to eat my words. And here I am telling everyone I'm a great. So how do we do this? How do we get good efficiency? Well, new refrigerant processes are coming out all the time. The pressures of these things are astounding. 500 PSI refrigerant pressures, variable speed compressors, and they've all got this. But what really makes them work better than the next brand is the controls. It's really all about how sophisticated the control package, How's the outdoor unit talking to the indoor unit? Are they matching speeds well? The controls are awesome. So here's what they look like. So here's the mini split, and then here's the multi split. We can see the two indoor units being operated from one outdoor unit there. Let's talk about displacement. So we are going to displace some of the heat that's being provided by the central heating system. We put in a mini split, it's going to take over some of the work. It's going to displace your heating system. We're not going to take the central system out of the house, but we're going to leave it there for backup. We're going to use it as little as possible because in many cases, we'll get into that a little later too, the mini splits or the ductless heat pump is more efficient. So what if we displace 80% of the heat? What's that look like? Well, let's look at the fuels. Here's a busy slide. And some of these numbers aren't current. So we have some prices in here. That's like a 5-year average if you include this last little bit of time that we've had cheap fuel. Let's take a look at the oil again. So 138,000 BTUs in a gallon of oil. We burn it at 85% efficiency, and we paid $3.22 a gallon for it. It costs about 27 bucks per million BTU, MMBTU. So what we've done here is we've broken down all the different units, all the different fuels into dollars per million BTU at average efficiencies in which we use these fuels. So you can see electric resistance here, 44 bucks per million BTU, and high efficiency natural gas, $16 per million BTU. So where does the main split heat pump come in? About $17.58 per million BTU. So right in here between pellets and cordwood, pretty close to cordwood. Make sense? 250% efficiency. Everybody know how we got there? Okay, so our average Vermont house uses about 75 million BTUs a year. And the fuels highlighted in yellow are the fuels that are more expensive than using a mini split heat pump. And oil costs about 2,000 bucks a year to heat the average house. Everybody agree? Somewhere in there? I don't know what kind of fuels you're using here, but we see that pretty typically around the state. It's a couple $1,000s a year to heat your house. More if you have electricity. A little more, propane's a little more expensive than oil. Here's what we can expect if we displace 80% of our oil or our propane with the mini split heat pump. So if our new system is a COP of 2.5, we could save about 600 bucks over oil cost and maybe $1,000 over propane. Let's look at that a little more carefully. So here's a house that we're displacing 80% of the heat with an 85% efficient oil system. So before, the house used 640 gallons of fuel, cost about $2,000 a year. And it used 88 million BTUs to generate 75 million BTUs because of the efficiency of burning the oil, right? Oil is up 85% efficient. That means we got to put more in than we get out. Okay, so afterwards, we displaced 80% of that oil system with our heat pump, and we used only 128 gallons of oil, but we used 7,000 kilowatt hours of electricity. So at 15 cents a kilowatt hour, that means we used $1,060 in electricity, about 400 bucks in oil. 1470 was our total cost, and before it was around 2,000, so we saved 590. Here's the cool thing: we also saved some BTUs because the heat pump is more efficient. We didn't have to put so many BTUs into the input equation. So because we had a 52% net reduction in BTUs, we saved some carbon. Pretty good savings. So that's all theoretical, and I just put in a couple slides. Oh, look at that, way down there. Of a real house where somebody put a real heat pump in a real house. 2-story house in Burlington, about 2,300 square feet. They did some weatherization. They tightened up the attic a little bit. Heat load around 54,000 BTUs an hour. And they used about 680 gallons of oil to heat this house. Sounds pretty similar to our other example. They put 2 mini splits in. One in the main kitchen dining room area and one in the master bedroom. And you can see what these guys look like. This is in the kitchen, next to the kitchen counter here. And then here's the one in the bedroom. So before, they used 684 gallons of oil. Now they adjusted that because they were getting their hot water off of the oil boiler. So they wanted to disaggregate some of that. So they said, well, about 584 gallons of that was for heat. And afterwards, they used 188 gallons of oil and 12,000 kilowatt hours. So we saved $870. Net savings, $594. So they used 6,900 kilowatt hours before they did this, and afterwards they used 12,000 kilowatt hours. So that means they gained about 6,200 kilowatt hours. We think that's about what they used for their heat pump, but we don't know that all of those kilowatt hours went to the heat pump. Right? We only know that the house used this before and used this after. So they could have done some other things. We don't know. You know, the occupancy could have changed. They could have got a new widescreen TV. Who knows what happened? But we're thinking, let's assume it all went to the heat pump, right? The net savings, about $600. Which is what our theoretical model showed us when we looked at, okay, average houses use this. This was a pretty average job. They displaced 73% of their conventional heating system and came out with a COP of about 2.2, and again, that assumes that all the electricity went to that heat pump. What do they cost? So, to get into a single zone ductless mini split is about $4,000. Now you can get into the multi-zone ones where there's like 2 indoor heads and 1 outdoor compressor at about $6,000, and then it starts getting more expensive. You start getting the fancy things like I talked about, like the flush mount cassette in the ceiling or the ducted systems, and it gets a little spendy pretty quick. Ground source heat pumps are very expensive. I haven't seen one that came in at $20,000. They tell me that that's the starting point, but it doesn't really happen in my experience. Mostly they are much more expensive than that. Let's talk about this. So, how are we doing? Is this stuff sitting? Is it like what you came for? I don't know. I can adjust it if you need. We want to have a good air-sealed and insulated building. So I would say that if I was going to do this in my house, I would go after the enclosure first. I'd go up in my attic, air seal my attic, I'd top off the insulation, I would do everything I could to make my house as efficient as I could make it before I started investing money in better heating systems. I just think it's the right way to go. Efficiency, conservation, and then we deal with renewables and fancy heating systems. So they work good in a building with an open floor plan. So in a room like this, it would be great. We put one in the middle of the room. It would fill the space with warm air. If your house is chopped up into little rooms, this may be hard for you. It may not get out into the rest of the house. It may stay in the one room. And you're going to be nice and warm in this room, but the rest of the house will be cold. Multi-story buildings are actually a little better. It's easier to move heat vertically than it is horizontally. So heat rises, and we can ride on the coattails of the convection of that, and we can get the heat upstairs pretty easily. But it's hard to get it way off. If you have a big rambling kind of ranch house, it's hard to get it to the back end of the building. We want a good backup system. We want a good existing system that we can use to take up that other 20% of the load or whatever it's going to be. It's nice if that existing system has multiple zones. So, for instance, with a hot water boiler, you might be able to turn the heat down in the living room and do that living room, dining room area with the heat pump, and then the back bedrooms and the upstairs you might want to get with their own thermostats that are tied into the boiler. It's nice if we can pick out zones of the house and say, this zone we want to use the heat pump, and that zone we'll use the conventional system. It helps to make the economics work if you have expensive heating fuel. So if you have propane or oil or electricity, we can replace those pretty cost effectively. If you have cordwood or a pellet stove, savings aren't so great. So there's not like pie in the sky awesome savings for everybody. It really matters what your existing conditions are. And if you have renewable electricity, if you have a solar system, you can net out the usage of your heat pump, and that works pretty sweet. So here's a good installation. Not really. It's all covered in ice here. It's sitting on the ground. So the outdoor unit in the wintertime is cooling off the outside air. So that's kind of how this works. We cool off the outside air, and then the byproduct of doing that is heat, which we bring in some. So if we take the outside air temperature from 0 to -20, we can move that heat inside. And when we take that outside air from 0 to -20, it's -20 degrees right where that coil is. Wicked cold. So it creates ice on the coil, and these things will go into a defrost mode, and they'll warm up the coil and melt all the ice off the coil. Great, works good. Except if it's sitting on the ground, where does all that water go? It just pools up on the bottom, and it turns into ice, and the water falls on top of more ice, and the ice builds up, and the next thing you know, the coil's locked up in a big ice block. So we have to get them up off the ground. We have to have what's called a pan heater. So underneath it is a little pan, and if we have a little heater that comes on in the pan when the thing's in defrost mode, we can keep that melted ice melted long enough to get it away from your pan. So you don't want it on the ground. You don't want it under the drip edge of the roof, right? If it's under the drip edge of the roof and the roof's dripping on the thing all the time, we're going to get a bunch of ice. And if it is, we better put a little cover or a little roof over the outdoor unit. We want the indoor unit placed in a space where it can throw its heat out, and it can effectively heat a large volume of space. We don't want it trapped in a little room. We want the line set penetrations sealed. I can't tell you how many times I go and look at a heat pump, and there's big gaping holes with a smaller line set going through the hole. And there's a bunch of cold air blowing in right there. And, you know, being an old energy efficiency guy, I'm like, I can see daylight from inside the house. It's terrible. The refrigerant lines need to be insulated. That means they need to be insulated all the way back to the unit. Sometimes I see installations where the refrigerant line is exposed copper like 6 or 8 inches away from the unit because they didn't get the insulation all the way back there. I want to make sure that it's insulated and protected. And the integration piece with the existing heating system is really important. So we can't overlook that. I've seen a number of great installations, but then nobody talked about how to interface with the existing heating system. So sometimes we need to move the thermostat. If the thermostat's in the living room and we put the mini split in the living room, we're going to satisfy the heating system thermostat with the mini split, and the boiler's going to shut off. And now the whole back end of the house is freezing because the boiler won't come on because the thermostat's being satisfied by the heat pump. So sometimes we need to move the thermostat, or just really think through our control strategies. How are these things going to relate to each other? What's going to happen here? It's usually not rocket science to do that. It's just a little common sense, but sometimes that piece gets missed. So I just want to put a little plug in your ear about that if you're going to do that. Like the heat pump water heater, these things make a little bit of noise. Mostly the outdoor unit. The indoor unit's really quiet, but you will hear it if it's very, very quiet in the room. Just, what is that? That noise didn't used to be there. a little background hum. Very, very quiet. I can't hear most of them because I have bad hearing, but I can definitely hear the outdoor ones. And sometimes, if the outdoor ones are mounted on a wall bracket on the wall, they can resonate in the framing of the wall, and you can hear them pretty good inside too. So it's not something I would consider putting outside the bedroom window. I like them if they're on the gable end of the house and not under the eaves, so the roof doesn't drip on them. You're going to see them. You're going to see the outdoor unit and you're going to see the indoor unit. They both need access to the air, so that means they both need to be exposed. We can't like build cabinets around them and hide them, or they won't work. Now, as you can imagine, we have something that's taking heat from the outdoor air and putting it inside. And when it gets cold outside, that thing is going to work harder and harder and harder to move heat from outdoors to indoors. And it will have decreased output as it gets colder and decreased efficiency as it gets colder. So it works harder to move fewer BTUs when it's 10 below zero out. But it still moves some heat, but its capacity goes down. Sometimes the electric system in some people's houses are kind of maxed out. So we're talking about putting a new 240 volt breaker in the house. And if your panel is like filled and there's no extra slots at the bottom of the panel, or if the service wire is really small and old, you maybe only have like a 60 amp service come into your house, and that's totally maxed out with what you're doing already, you may have to upgrade the service, your electrical service, in order to install the heat pump. Now that adds money to the installation costs, so there goes your savings. Not that it can't be done or shouldn't be done. You may want to upgrade your service anyway for other reasons, but it sure is going to make your installation a little more pricey. This doesn't come up a lot, but just so you know going into it, some of these you can only set them down to like 54 degrees. So the low end temperature on the thermostat setting, it won't go all the way to like 40 or 30. I like it warmer than 54 in my house, so not a really big issue for me. But some people want to turn it way down. Now, I don't recommend, here I go, going back on the things that I've been saying for years, but I don't want to recommend that you set this back. I think the way to run the main split heat pump is to set it and forget it. Put the thing on whatever temperature you like it in the room, and leave it alone. Let it work its magic. Remember those really sophisticated controls? If you start doing this on top of all those sophisticated controls, the thing will have weird cycling behavior. Here's a really cool example. Habitat for Humanity built 2 homes in Charlotte. Well, they built 3. 2 of them are pretty much identical. Super efficient, like passive house level homes. And in one of the homes, a nice thrifty family of 4 Vermonters moved in there, and they kept it at 64, and then they set it back to 50 every night, and they were really thrifty with their thermostat. And in the house next door, a family of Somali refugees moves in, and they kept their house at like 80, because that's as low as they could go. I mean, they're not into cold temperatures, they rock it, and they left it alone. How high does this thing go? Let's leave it there. And the difference in energy to heat those 2 houses was negligible, right? And that's strictly due to the fact that those guys were doing all those setbacks, and that heat pump had to work so hard when it was 20 below out, and they set their heat down to 50, and then they wanted to recharge it back up to 65 in the morning. That thing worked all day trying to do that. And it cycled, it did all this weird cycling behavior. I saw the monitoring data, and it was like up and down, spike, all over the place. And the other house was like 85 degrees, rock steady. So don't mess around with the temperature too much. All right. Here's what Efficiency Vermont can do for you. Okay, so we have this program where we buy down the cost of the heat pump. And we're typically giving a $300 to $400 discount. The $400 discount is going towards some of the more elaborate multi-split installations. Basically, it's $300 for most of the mini splits. So whoever goes into the store to buy this thing, whether it's you or your contractor, if they walk into a participating wholesaler to buy the equipment, he marks the cost down $300 right there at the spot. So there's no coupons, there's no rebates. He takes a little bit of basic information about the installation, like what town's it going in? Thanks. And then he applies to us to pay him back for the discount that he gave us. Do you have a question?
Has to be bought in Vermont.
Has to be bought in Vermont. All the participating wholesalers are all going to be Vermont Street. So yeah, there's no rebates, no mail-in forms. You don't have to wait for a check. It happens right on the spot. So we have some eligibility requirements on equipment. There's some specs that Efficiency Vermont developed for cold climate heat pumps to be eligible for our rebate program. And these, whether or not you're getting a rebate from us or you care about that, it's a good set of specs for a cold climate heat pump. These guys thought a lot about it. And for single zone, HSPF of 10.3, EER of 12, and the SEER of 20. Some heat pumps are significantly better numbers than that, but that's like the minimum that we'll accept. The multi-zone, the numbers are a little bit lower, but pretty high still. So we said they gotta work at cold temperatures. That's what we're doing here. We want a COP of 1.75 or greater when it's 5 degrees out. And we want them rated for use at -5 or below. And most of the ones on our qualified products list down below, click the link, are rated for use at like -15 and even lower. So they really do work at cold temps, but again, they have decreased efficiency and decreased capacity. They work really hard to move a little bit of heat when it's super cold out. Here's our participating distributors. Oh wait, back up, I forgot something. Is there anybody here who's an installer or raise your hand if you are here as a vendor or an installer for heat pumps. These guys back here can answer your questions, particulars. If you want to talk about my house, how do I, and go to these guys with that. It'd be a great resource for you. Here's the companies that manufacture, these 5 companies all manufacture equipment that meets our spec. Here's the participating dealers. So this is where you can go to buy them and get that rebate from Efficiency Vermont. What if you want to take out a loan? If you're going to take out a loan, I'm thinking you might want to wrap up a couple of other things. Remember that example that I showed you of the house in Burlington? That guy did a little bit of work in his attic too. So if you have some things like you've been putting off about doing energy efficiency work on your house, it's a really good idea to package it all up into one loan. And if you do it right, if you get the right loan at the right term, at the right rate, and you do the right work on your house, it's possible that your energy savings will make that loan payment for you, right? It's a little bit more. But the way I like to think about it is not with payback. So I'm going to pay on this loan for 10 years, and all the stuff will get paid off, and then all the savings will be mine. Nobody thinks 10 years out, right? A lot of people are like, I don't know how long I'm going to be in this house, or is it really worth it to do it? Something cool will come along in 5 years, and I'll be stuck with this 10-year thing, right? So what I'm saying is, if the numbers work now, if you can take that loan out, and if you can make that loan pay for itself with energy savings, that's positive cash flow from day one. Then you have the cost of not doing it versus the cost of doing it, right? So whole different lens to look at it through. So there's some financing options. There's a few different loans I've listed up here. Heat Saver loan, the PACE loan is through your community. Heat Saver loan is being done with Vermont State Employees Credit Union and Opportunities Credit Union. We have some business loans, farm, agricultural programs. Here's the Heat Saver loan. This thing's cool. So there's different income tiers. Household income below 64, between 64 and 96, and above $96,000, you get some different rates. The terms, 5-year term, you get a little bit better rate, but you can borrow up to $35,000 for up to 15 years. So if you want to wrap up an improvement package in your house and you want to borrow money to do it, you can really get the savings greater than the loan payment. People are doing this, it works in some cases. If your house, if you're burning wood and you've already done some weatherization on your house, maybe this doesn't make sense, you know? But if you've got like a leaky old house and you've been putting off doing some energy efficiency work on it, and you've got, a low efficiency, high cost fuel, this might make a lot of sense for you. Okay, so get an energy audit. I'm gonna go back to weatherizing the building first and then putting the heat pump on it. Get an energy audit, find out where you're at, What is the condition that you're starting with? If you just start throwing measures at the house, you don't know if you're doing the right, that's like taking your car to the mechanic and saying, just start changing parts, and I want it to run better. Like have him do a diagnosis, right? So you can go and get an energy audit, they'll look at the air leakage levels, they got some great diagnostic equipment, they'll give you a report, they'll look at health and safety issues in your house that could be associated, that could be made worse if they tighten up the house. Sometimes the chimneys don't draft as well. Average cost about $400. It's a great way to find out where you're at and what makes sense for you, and I really suggest you start there. All right, enough said. Look for the Smart Choice label if you go to the store to buy appliances and stuff, because Efficiency Vermont has thought about like which ones make the most sense for the Smart Choice label. And that's the end of my program. So, any questions at this point? Or any questions you got to get off your chest? There's one.
A couple of times you talked about the attic.
Yep.
And our understanding, because we're kind of new to the front, but our understanding is you don't really want to over-insulate the attic in cold temperatures because it can lead to ice. It sounds like the right thing to do for a heat pump, but it'll actually keep the roof warm enough so that it'll actually melt snow and then freeze back up.
More insulation between the heated space and the cold attic reduces ice dams. So if you have ice dams, definitely get some work done in your attic. Give you a lowdown on that. Anybody else? Come back here. I've seen people do it, but it has to be a heck of a house. It has to be like, you gotta throw a lot of money at your house to avoid having the backup system. And then it's kind of a gamble, right? The theory being that like when it gets super cold, the big Arctic high comes in and it gets like sub-zero, that there's sun available. So they're having sort of a passive solar heat input from that sun that's available during the Arctic high. And they're saying that in the capacity of the building to maintain heat for maybe a day or two on its own. I saw a really cool house in Stowe. The guy was a skier. He lived in Massachusetts or something, and he built this like rockin' passive house in Stowe. And he's like, I'm not gonna heat it when I'm not there, and it's not gonna freeze. I leave the water on. He just cowboyed it. Yeah, this is gonna work. And we put monitoring systems in there. I was watching the temperatures in that house, like, oh, it's 20 degrees. What's happening? Okay, it's 0. What's happening? It's minus 40. What's going on? 50 degrees in this sense. So 50 degrees isn't that comfortable. So if we don't have power, or if the heating system shuts off because it's too cold for it to work, which can happen, I don't know. I'm not comfortable at 50. I want backup heat. So some people are doing backup heat like a little wood stove. Great solution. Some people are using a little bit of electric resistance backup heat, but not buying the big fossil fuel fired centrally distributed heating system. How about back there?
Can you run both an air-to-air system along with an air-to-water under the same system? In other words, if you've got part of your house that has passive radiant heat, with water.
You've got some radiant heat in your house.
Can you run water through part of your slab while at the same off the same unit running an air-to-air?
That's coming up. So, yeah, remember I said keep your eye out for the water-to-water heat pumps. There are some that will do like a multi-split heat pump where one of the indoor units can be a wall mount air indoor unit, and the other one can be a water tank. We're moving water into heat into that water tank, and then you can move that through the house. So that's coming up. We actually have a R&D project right now that we just got funding for to put 4 of these things in and watch them go and see if they work. No, we got the places to test them. We're just hoping we can actually get the things imported because they're not like ready for America. You have one here?
Yeah, a question about when you need a backup system.
Yeah.
There are many buildings, at least in southern Vermont and southern New Hampshire, that have gone through 5 or 7 or 8 winters just fine without any backup system. Just right near, not too far from the Putney School Field House.
Yep.
There's a number of buildings, large office building in Keene, a small office building, other buildings that brand new buildings that have just
Commercial buildings, much easier.
air source heat pump system.
Much easier than residential buildings. And so the gentleman made the comment that there are plenty of houses around here that are doing that. No backup, just air source heat pump. And that's cool, but be careful thinking that your house is that house. Because
I guess a related question on that.
they're not all the same.
Like you talk, aren't the ones in Charlotte, Vermont, and the Habitat for Humanity house, that doesn't have any backup, does it?
They're passive houses, and they actually did use a couple of plug-in electric space heaters for backup. But yeah, there's no backup there. I don't advocate that. I mean, you can do it, but I feel really uncomfortable coming to a group of homeowners and saying, "Don't worry about it."
Yeah, but I think the question.
I helped design, and I currently spend a lot of my time implementing the high performance homes program at Efficiency Vermont, which is residential new construction, super insulated, high performance houses, which is what we're talking about. And 99% of those houses have some other kind of way to make heat besides their heat pump. Usually it's a wood stove. People like the resiliency of saying, okay, all else fails, I just stoke that baby up and I got heat.
Right, in case the electricity goes out, yeah.
In case electricity goes out, or in case their heat pump isn't working or able to meet the heating requirements of the building. Remember the diminished capacity at very cold temperatures? So this thing, at 17 degrees, your heat pump might be able to make 15,000 BTUs an hour. And your house might have a heat load of 15,000 BTUs an hour. So what happens at minus 30 degrees? Your heat pump doesn't work, period. It's like, yeah, I'm checking out. There's nothing I can do here. Some of them do that. Some of them will continue to operate, but move like 2,000 or 3,000 BTUs an hour into your house. So the concept of like, is your building resilient enough to handle doing just municipal heat pump is a function of the envelope of the building. So the enclosure of the building becomes part of the heating system at that point. And you have to really have that enclosure be bomber if you're gonna go there. All right. I think this guy,
Can you say a word or two about the dehumidifying properties of mini split?
dehumidifying properties
Yeah.
in cooling mode, they
well,
will dehumidify your house much like an air conditioner will.
okay.
And there is a little condensate drip on the indoor unit that has to be run somewhere. I was talking about the heat pump water here doing dehumidification.
Yes.
And that happens whenever it's running. So it's the cold air that's being generated on the backside of the heat pump creates a condensing surface on the coil of that heat pump. And that will suck some moisture out of the air, put it into a condensate drip, and run it away somewhere. And as long as that thing's running and there's moisture in the air that can condense on that cold surface, it's doing dehumidification.
In a rental, so I understand you were talking about the more open the space is, the better for these things. A good open space is a good
for
Have it.
the main split heat pump,
Yeah.
or for the water heater, where are we going with this?
No, not the water heater.
Okay, okay.
For the heater.
For the heat pump.
For the heat pump. So in a rental situation where people have a room, I'd like to give two rooms this thing, but it's not part of the whole house, so to speak. But they're cold rooms. Is that an
Yeah,
appropriate?
you can put them in a room. You can put a multi-split system in. I've seen multi-split in, and a head in each bedroom, and then a big one in the living room. There's all kinds of, talk to these guys about how to set that up. Yeah.
Of the models that you've mentioned in manufacturers, what's the durability of a mini split system and what's the annual maintenance?
Annual maintenance and durability. Any of the vendors want to take that on? The question is, what's the durability and annual maintenance? So what's the average warranty?
Warranty, at least I can speak for Fujitsu. Out of the box, 7 years on compressor, 5 years on parts. If you register the unit online, it's 10 years compressor, 10 years parts.
Okay, so 10 years compressor parts if you register online. How about Mike, do you want to talk about maintenance?
Maintenance is pretty simple. There's a couple of filters inside the unit that you take out and wash out and put back in. They're permanent filters. There are a couple of disposable filters you can buy from your dealer that cost about maybe $20 a year. If you're concerned about air freshening, they have that capability. But the primary thing that you want to prevent is dirt and dust from plugging up the coil. It reduces the airflow. So you want to keep on those filters probably, every couple of months. Take them out and shake them out and clean them out. Outside unit, pretty much leaves get in and block the airflow. So once a year, take a hose and hose it down.
So keep them clean. Keep the filters clean. Keep the leaves out of the outdoor unit. That kind of stuff. Sounds like they have good warranties and are not too tricky to take care of. Sorry.
You talked about ground source heat pumps being a lot more expensive, but if you were gonna tie them into an existing system, it seems like that would make the most sense, but what makes the ground source heat pump that much more expensive?
The
Is it
outdoors.
the excavating?
The well or the trenches or the excavation, that stuff. The indoor unit is a little more money. I mean, $10,000 range, $10,000 for the indoor piece of it sometimes.
Yeah.
All depends. Careful engineering on each system, pay a little bit for that. And then, yeah, you can tie it to the indoor distribution system, whether it's water or air. But, yeah, with a ground source heat pump, the outdoor work can get real expensive real fast. So there are a couple of types of ground source heat pumps. There's the trench type that I showed, and then there's the aquifer type I showed. Like usually it's a standing column, or a drilled well. And if you extract all the heat out of the water in that drilled well, you're cooling that well down, and you run into the same problem you have with the air source heat pumps, where your heat source is cooled off, and it's harder to extract heat out. So you run into these things. There are solutions. They cost money. There's engineering options, and that costs money. The whole thing gets going.
Yeah.
You can imagine, right?
Yeah.
What are we doing for time? We take one more? Okay, one more question in the back. Do you want to avoid the situation where it's gone into very low efficiency mode and it's more expensive to produce heat with your heat pump than it might be with your backup system?
Right.
That's a good strategy. I recommend that if you install a heat pump in your house and you're trying to figure out what's the right balance, how do we use the backup system and how do we use it, I recommend just run the heat pump and not the other system and see what happens. See how much of a load that thing will do. Like take it out on the highway and put the pedal down and see what that baby will do. And then that starts to give you an inkling of what it's capable of at different temperatures, and you and then develop your own strategies on how to stay warm and what works best for you. Okay, we're gonna stop questions here. Awesome questions. Thanks, everybody. We're gonna turn it over to those people.
Now we're going to have a testimony from Lester Humphreys. Lester's the former chair of the Brattleboro Energy Committee, and he's going to talk about his experience purchasing and installing a heat pump water heater.
Hi everyone, we've been here a while, so this won't take too long here. Heat pump hot water heater that's in our basement that was talked about before. It looks like a regular hot water heater. On top is the heat pump. Cold air comes out of here. There is down here, there's a little condensation pump which takes the humidity that this thing dumps out and puts it into a drain over there. And it runs off 220, needs a 220 plug. And this is the important thing. I don't know if you can see this, but this is right here it says 492 to 544, and this thing's running at 201. So this is off the chart as far as savings. And this is what they estimate for kilowatt hour use for a year. And it says in the fine print that it may vary depending on electric rates in your area. So I did some math based on our electric rates here in Brattleboro. And what it came out to was $277 a year for the heat pump, $23 a month. Straight electric would be $677.56. So the savings over straight electric hot water heater, $400 a year, $33 a month, or $4,000 over 10 years. So if you've got a straight electric hot water heater, there's significant savings here. And let me just back up for a second. Ours is installed in our basement. I talked about a little bit about where to install it. So there are some exceptions. Don't always want to switch to this, but the savings are really significant. Compared to propane, same price for the heat pump at $2.85 a gallon, which is what I just looked up today, our price in our area. The cost of $733.61. So a savings of $456 a year, $38 a month. $45.64 over 10 years over your standard propane hot water heater in your basement. Oil. This is a tankless coil. So if you've got a system where there's no separate tank, but it's coming off your boiler, hot water's coming off your boiler, there's a coil inside your boiler, at $2.30 a gallon, which is low. This is today's price, which is amazingly low right now. You get $576 a year, $48 a month, savings of roughly $300 a year, $25 a month, or about $3,000 over 10 years. Those coil systems work pretty well in the wintertime when your boiler's going, but in the summertime, you're heating up a lot of water just to create some hot in your boiler, just to create some hot water. And so these things are really inefficient in the summertime. And if you have one of these, just really think about switching to a heat pump. And then this is what we had, which was an indirect off oil, which is a separate tank that sits off your oil boiler. And they're actually fairly efficient, but there's still $1,400 in savings at $2.30 a gallon. So if we get up, to normal oil prices, the savings will go up from here. In our case, our tank that was sitting next to our boiler needed to be replaced, and so we were looking at $1,800 to replace that versus just going with the heat pump hot water heater. And this is what, as best I could, this is what I tracked for us. with the heat pump, our electric bill went up by about $21 a month, $257, and before we were paying $443.37, savings $186 a year, for about $1856 over 10 years. But we basically got our system, our heat pump, for the same cost as what we were looking at for replacing our tank, and we're getting the savings. So it made a lot of sense for our case. And in oil, we're replacing one of the more efficient systems. If you have a brand new, System 2000 oil system, and with the tank on it, stuff like that, then you're not going to see huge savings. But if you got standard propane or coil or some of the other, or electric, the savings are really significant. Things that we learned along the way is you can put it in heat pump mode rather than hybrid mode. We've had it in hybrid mode originally, which is sort of using a combination of the heat pump and a regular heating rod in the tank, and we didn't see all the savings. Our basement is about 3 degrees cooler and drier with this thing running. And the unit is about as noisy as our boiler is. It's interesting. When I'm upstairs, I hear the boiler come on, and I hear the heat pump hot water heater come on, and they sound really similar. And hot water is hot water. The big difference we notice is the savings.
When did you install your?
It was about a year and a half ago.
When you switched to running it in heat pump only mode,
Yeah.
did you ever notice less hot water, like you run out at all? Was it able to keep up with your family?
It was able to keep up.
How many people?
This is an 80-gallon tank. This is a bigger one,
okay.
and we have 5 people.
So that's a lot of hot water.
And we've never had a problem. It does matter. We have relatively efficient shower heads and things. We have our washing machine is a front loader, stuff like that. If you're a really heavy water user, then you've got to size it just like you've got to size anything.
What did the unit fully installed cost you about?
Now this is an 80-gallon. This is a big one. We've got 5 people, so this is more expensive. Ours was $1,942 for the. I think the 50-gallon ones, which most people can get away with, are more like $1,200, $1,300, something like that.
Yeah, I mean, they're around $1,200 or $1,300 for most of them. And again, there's that Efficiency Vermont $400 incentive.
Yeah.
So, I mean, if that gets it down to $800, that's right in there with buying a regular water heater.
Yeah. The installation cost for us was $980. Again, I think, $700, $800. And then the $400 rebate. So the total was $2,500. And like I said, we were looking at $1,800 for the tank, for replacing the tank that was leaking, and then installation costs on top of that. So we did pretty well.
Is that a Ream or a GE?
That's Whirlpool, which is just brand name. I think it's American hot water company or something, Standard or something like that. You see them under, they look identical, but they're under a bunch of different brand names, but it's the larger 80-gallon one.
Because the question actually for Efficiency Vermont is, what if you wanted less than a 50-gallon tank? Were you saying that
So you gotta buy the tank that comes with the heat pump on top of it. So you're kind of limited in terms of the tank sizes that you want. There's standard sizes around 50.
50 and 80 is what I've seen.
Yeah.
If it's down in the basement, it's not heated. That, let's say, sits at about a 40 degree or 45 degree.
You don't want to do
You don't wanna run that.
This thing will, well, in the summertime it'd be great. In the summertime it'll work fine. But This thing will kick into being a standard hot water heater below 45 degrees or so. So you're basically paying for the heat pump, but you're just using it like a regular hot water heater in the wintertime. But in the summertime, you'll get the savings. You have to figure it out whether it works for you. All right. Excellent.
Our next presenter is Helen Brown from Green Mountain Power, and Helen works at the Energy Innovation Center in Rutland. She's going to talk about GMP's heat pump lease program.
Yes, we have a heat pump leasing program, and it is a heat pump to hot water heater. We lease those as well. All right. So usually at work, my day will start off with answering a lot of questions, such as the things that Matt addressed. So that was really nice, and the next time I get a phone call, I'm just going to call up Matt and say, would you talk to so-and-so? And then I will get into the leasing part of the program. So the way in which we work it is, we have, with the heat pump, we have 4 different size BTUs. Our smallest is a 9,000 BTU, and our largest is an 18,000 BTU. Then we have 3 different leasing terms. We have a 7-year, 10, and 15-year leasing terms. So when you do the math, the 4 size units and the 3 different terms, that's 12 different price points. Our lowest price point is $40 a month, and our highest is $75 a month. And that is for a mini split, such as Matt explained. Now we also have a multi-head solution as well, but that pricing is a little bit more complex, so we don't really have that. I don't talk much about that because that would really require more question and answer session to get into those numbers. All right. Same thing for the heat pump hot water tank. It's a 15-year term, and we have the 50-gallon tank, and we also have the 80-gallon tank. All right. And those prices, I have some prices on that in the other room, if you're interested. But the way we start the program is a conversation with an energy specialist like myself or somebody else at the Energy Innovation Center, which is in downtown Rutland, and we'll go over a couple questions with you. We'll ask you what your goals are. We'll ask you what your current heating sources are. What are your habits in the household? Are you there 5 days a week, or are you 7 days a week, or are you a weekend skier that comes up? So then we'll kind of talk about the possible solutions and what the numbers might look like for you. Based on that, if it sounds like it's a good place for your home to put one of these 2 products, we will send an assessor to the house, and once again, they'll review your goals with you. They'll look at your floor plan. They'll come up with a cost analysis for you, so you can see what your current costs are versus what your potential future costs will be. And then based on that, we will have a contractor come to the house and do the installation for you. The bill, the cost of it, the leasing cost is in your Green Mountain Power bill. This is for Green Mountain Power customers. I need to preface that. And it is, like I said, a 15, 10, or 7-year lease. We do the installation is included in the leasing payment. We also warranty the product, so if anything goes wrong, whether it's a part or the whole unit, if there's something wrong, we would replace just a part or the entire unit. We also come once a year, we'll do maintenance on the unit for you. And the unit is, we will retire it in your home if you continue through the entire leasing term.
Then you get to keep it in?
Can we, I'm sorry, yeah.
What did you say, you retire it?
We retire it in your home.
You get to keep it?
Yes, you get to keep it, yeah. The only thing at that point that goes away is as far as the warranty and also the maintenance that we do on it. So,
Does the warranty run as long as the lease?
yes, yes it does.
Do you have a price on the 50-gallon hot water meter?
I do have one.
That you can't just.
It's over, I just don't remember the numbers because the numbers are all over the place for us. So, yeah, I do have that right up in the other room. Yep.
It's something you can buy out of that lease.
Yes, you can. Yeah. They will give you a price. If you just work with us, we'll give you what that buyout price is. Did you have a question?
Yeah, so what kind of maintenance do you think is necessary? Just a few pieces.
It's pretty much the same that was stated earlier. We will come every year and do that outside unit, but we don't do anything with the inside unit unless there's something that you call us and ask us to come take a look at it, because that does require somebody being in the home to do the annual maintenance. And typically it's just the outside unit that needs it. And as far as the maintenance inside, what was stated about cleaning the filters is very important. From what we have found, that we get a lot of phone calls from people that, all of a sudden they're not too happy with the way things are going. And the number one culprit is the fact that they have not been cleaning the filters. That's the number one thing.
When you do a cost analysis, that's to compare to what your current system is, would you also do a cost analysis for leasing versus purchase?
Well, to tell you the truth, probably not, because that all depends on the product that you get. We have a Daikin, Mitsubishi, and Fujitsu. So there's all different products that are available. And I wrote down the numbers that Matt put up on the board because I get asked that question a lot. But what we will do is we'll keep in mind things like, are you using, if we're comparing it to oil, we'll say, okay, are you using hot water, your oil to heat your hot water? So we'll put those numbers into the tablet, because I think the average on a national level, they say it's 20% of your heating cost if you're using for your water. So we'll, figure those numbers into it as well. For us, the first thing we start with is, what are your goals? And for most people, if they say it's a financial thing, that they want to get their heating costs from here to here, and if we're not able to do that, we'll say, you're doing great with what you're doing, stick with it. But if their goal is something like comfort or change of lifestyle, if they're sick of cutting wood, stacking wood, and so forth, because wood is very energy efficient and it's economical compared to fossil fuels for a heating source. So if somebody is trying to get away from that, then they're willing to pay that little bit more money for the leasing program. So, but there's, every house is a little bit different. Everybody's solution is a little bit different. So that's why we try to take the time on the phone with you ahead of time, and then in the house. And there's no cost for the assessment. Any other questions at this time? And one other thing is that I should have mentioned is, if you're not into the leasing thing, we have partnered with NeighborWorks of Vermont, and we have worked with them so that you can get a low interest loan, and it's income based, just like the slide that Matt had a minute ago. And if you want to use the Vermont Power bill to pay off that financing, that's available to you. Okay, and that financing, by the way, can be used for many renewable energy products in your home, and you can do the payment on your Vermont Power bill. Okay? One more question?
Are those interest rates comparable or identical to the ones in the other?
Very similar. I saw the bottom tier, which was, I think his number was 64,000, and below is anywhere from 0 to 1.99. And I think the one I have is like 65,000, but it's still for the income level, but it's still 1.99. So very comfortable.
Hi everybody, thanks for sticking around. I know financing isn't always the most exciting portion, but I appreciate the time. My name's Laurie, and I work at VSUCU. We're a credit union. We have a branch right here in Brattleboro at the Price Chopper Plaza, and Lisa DiBernardo is here. She's the branch manager down at that branch. So what I want to talk about is just some of the options that you have available to you, and Matt mentioned Heat Saver loans, so we'll talk about that along with some other new things that are going on for us. So basically, what Be Green is our suite of energy saving loans. They can be used for anything, any project at your house. We've talked a lot about weatherization here as well. That would save you energy and therefore money at your home. So anything from the heat pump that you see there, which we're talking about here today, bicycles, solar, weatherization, that's a new efficient heating system, a primary heating system. That heat pump system is actually at my boss's house in Montpelier, so he has electric resistance heat, and he's had this for about a year. And he said definitely saving him about 30%. He has a ranch, it's like a raised ranch, but he has electric resistance heat, which he never changed out. But he said during those, the shoulder season, the fall and the spring, this has been really efficient, money-saving addition for him. So we have proof that it's working for us. So this is, Matt talked a lot about how, these projects can be cash positive. We like to think that they will be cash positive from the very outset, from the moment you take out the loan and start paying on a loan, and you're paying those monthly payments with the savings that you're getting. So this is actually an Efficiency Vermont graphic just showing, once you've started your loan payments, when the term is finished, you're getting those savings still. I mean, it might be 10 years out, but it might not be. So after your loan is paid off, you're getting those savings on a regular basis you can use for other things. Basically, our Be Green program, and I have lots of these brochures next door, some here too. This is the brochure. You can take one, and it has a little rate sheet inside. There's two options that you can choose from for heat pumps or for a solar system, and basically those would be secured or unsecured loans. So a secured loan means it's, you've got collateral like a home equity loan, and that's going to be where you get your very best interest rate. Unsecured loan, we've got several options there as well. Actually, the green vehicle loan isn't really unsecured since the car is the collateral. But for a heat pump, $4,500, most people are probably going to go with an unsecured loan. So the Heat Saver loan is really what is going to be best. It's kind of on a limited time. This is a state-funded grant program. So this is what the form looks like. It's a flyer and a form. We have it on our website. So the Department of Public Service is the funder, and they have made this grant money available to basically buy down the rate. So the rate you ordinarily would have gotten through a regular Be Green loan is being bought down by the state. And they're doing this on secured or unsecured loans, but most of ours have been unsecured. The maximum amount that you can borrow is $35,000, which is great because you can bundle projects. If you're thinking about doing the heat pump installation, you really should be considering the weatherization piece. That's going to make it a much more effective installation for you. And then there are eligible installers, but there's many throughout the state that are in the EEN, which is the Efficiency Excellence Network that Efficiency Vermont manages. So the eligible purchases are the home weatherization projects, high performance oil or propane heating systems, the cold climate heat pumps, central pellet heating systems, and domestic hot water. So again, that's what the form looks like. These are income-based. So if your gross income in your household is below $64,160, you can get a 5-year loan for as low as 0%. So it's free money. I mean, it's kind of an amazing deal when you combine it with the rebates that are available. We've done many in that category. So far we've closed 100 loans for this program, and we started last November, and most of them have been since April. So we're about halfway through our grant right now. That money's been going fast. So if you're interested at all, just saying, we're about halfway through. So that's the heat saver loan. I just wanted, while I have the chance to get in front of you, we've got two new exciting loan programs too for solar. How many people have solar right now, solar PV? Oh, quite a few of you do. So what these are we additionally were awarded 2 other grants from the state, and it's the same kind of deal. There's one for Windham County residents and one for state, Vermont state residents. And I'll just describe them quickly, and then I'll leave you with some paperwork, and you can look that over. One is called the Windham Solar Loan, so this is for if you want to install solar at your house, solar PV or hot water. Could be on your roof or your property. The other is the community solar loan. So this is where the panels are in a community array somewhere. There's several of those projects around this area. So these are the 2 eligibility, what makes them eligible for either residential or group net meter community purchases. There's the eligible. So we might be adding to the list if installers want to participate, but when you go to our website, you'll see the list. So the Windham Solar Loan, just quickly, state funded here, this maximum loan amount is $40,000. Maximum term is 15 years, and the income requirements are here. So these match up with Brattleboro area income eligibility. So the steepest, the biggest discount's going to be for the lowest income, and that's 1.5% off of the rate you ordinarily would get. And I have an example coming up. So it's 1.5% for the lowest income tier, 1% off for the middle, and 0.5% off for the highest. So everybody would get a discount no matter where you fall. The community solar loan, again, it's state funded for Vermont residents up to $40,000 in 15 years. Again, you have to use the eligible contractors. Here's the form and the income eligibility. This is based on Vermont eligibility requirements, so for the whole state, because it's statewide. Same thing though, 0.5%, 1%, and 1.5%. So those are the 2 loans, and how you access them is you get a quote from an installer or a company. You decide which one works best for you, the secured or the unsecured. You find your income tier. You deduct the corresponding buy down amount from the initial rate, and then you can apply online or with Lisa at the branch or online, or you can call us. So an example, if you borrowed $20,000 and your income was $60,000, like your household income, and you started at a 5.9%, so that would be a 15-year term, 5.9% for an unsecured loan. You would have a 4.9% rate applied, and there's the calculation, the monthly payments and so forth. So that's pretty much how it works. Of course, if you go with a home equity loan, a 10-year loan starts at lowest is 3.75%. So if you apply a percent off of that, you're down to 2.75% for a 10-year loan. So it's really is the goal of this is to make the financing for solar affordable for more people that ordinarily might not be able to afford this. And you can be a renter too, by the way. If for community solar, you don't have to own your own home, and you could, because if you're in GMP territory, you can transfer the credits to another. If you're moving or whatever, or if you're in your house now and you're going to downsize, if you stay in GMP territory, you can take it with you. You can transfer it to a family member. So the application steps, this is really tiny. Looks a lot bigger on your computer. You work with a company, you fill out the form with the installer, and it's on the back side of the flyer. And you provide a copy of the quote and the form, and we can get decisions to you in a day or two, a business day or two.
Can you secure the loan with the panels, or does it have to be home equity?
It's a home equity. We actually don't secure the loan with the panels. It's a very complicated process involving getting the serial number on every single panel and on the inverter, or multiple inverters if there's more than one. So, you know, lots of times installers we tried it, and they would say, well, I've got 30 panels on site, 2 of them had to go back to the warehouse, we're getting 2 more, and those are gonna be different serial numbers.
Right.
Well, you've already filed the paperwork with the state to secure a lien on the first 30, and then you have to tell them, and it costs, I don't know, $10 every time you file for each piece. So we decided that we were good with this model, and honestly, the loans are very good. People who are gonna go down the route of, you know, doing a solar project are pretty creditworthy. They're good loans. We've only had 4 defaults, and 2 were from deaths and 2 were because of divorces. So, any other questions? I have the paperwork if you're interested. Yes.
I just wanted to say that I've used you all both for mini split air source heat pump, and then we're in the process of signing up for community solar that is soon to be built.
Yes.
And it was an easy process. The rates were very good, very competitive.
Great.
And we don't have a lot of income, so we got a good rate. So if
Excellent.
we're expecting, the expectation is once we've even gone through a year with the solar panels, that our monthly payment for the loan will be less than our electric bill would have been.
Yep.
So,
That's
and then in
great.
10 years, we have none,
Right.
and we can.
You effectively own your power.
And we can give it to our children.
Right.
So definitely it's worth looking at if you want to go that kind of route.
Great, thanks. And we've been really pleased. We partner with the state and Efficiency Vermont to sort of, you know, get the eligibility figured out. We're happy to work with people on projects. I know Lisa's done several of these loans for Heat Saver, and she's worked with people on the solar too. So, you know, if you have questions, you can see me after or see Lisa. Are there any other questions about the loans or? Good to go. Okay.
Are there any other questions for any of the presenters before we wrap up? Please be sure to fill out your question.
I'm sorry. For a long time, the state was giving an encouragement grant or tax deductions and all of that for people who went solar. Is that still in effect, or is that kind of grandfathered itself out of the way?
Yeah, that's not in effect anymore. Those were the rebates that were offered for solar, and they got down to 25 cents a watt. You know, they were really big for a long time, and now they sort of were really designed to incentivize the business and, you know, solar uptake in Vermont, and they kind of did their job, and they you know, sunsetted them. Really, the thing to keep in mind is that the 30% federal tax credit, of course, is also set to sunset December of next year. You know, we don't know if it's going to totally, fully be retired or if they're going to extend it in some smaller way. But there is a little sense of urgency, and also the regulatory environment right now, that even GMP is getting close to their 15% cap in terms of what their obligation to provide for solar. So, you know, there's some urgency, but you know, Vermont's really got great, you know, they are very solar friendly. So hopefully all of, you know, some of the incentives will continue. But, you know, Efficiency Vermont does quite a bit for the rebates for a lot of the technology that's, you know, not solar. I don't know if they're doing domestic hot water.
We don't do renewables at all.
No.
Efficiency Vermont's order of appointment with the Department of Public Service explicitly excludes us from doing any renewable.
However, the Clean Energy Development Fund is the fund that is going towards, that's funding these loans, these solar loans. So especially the Wyndham one, that one is from money from the Vermont Yankee closing. So that money was specifically set aside for Wyndham County residents and also the businesses that work here. You know, meant to be an economic development tool as well.
Sure, one more sort of question on that. If a person wants to get started into this whole thing, I see a whole lot of people who have fingers in the pot.
Yeah.
And depending if I go to you or if I go to Energy Vermont or if I go to Green Mountain Power, everybody's kind of got fingers in it. And it gets terribly confusing in terms of am I getting the best information? If one is started, where is the best place to start at this point?
Well, it depends on what you're starting with. You know, I guess I agree with Matt that, you know, really the place to start is sort of, you know, with your building envelope and kind of understanding, well, what do I have now? And in terms of my house, and tightening that up and doing that efficiency work. You know, some people are it's like a continuum. They've already done that piece. So now they're on to doing, well, maybe I've tightened up my building. Maybe the next step is to kind of deal with my heating system. You know, for one reason or another, I don't like my heating system, or it could be better. Here's what I need to do. And Efficiency Vermont does quite a bit in that area because they are the energy. The Efficiency Excellence Network is this whole network of heating contractors that, you know, are working with Efficiency Vermont to deploy better technology that's more efficient for people. So if you look at what's eligible for their propane and oil furnaces, and you know, Matt said, you know, it's going to be tough to totally replace them. You know, they have pretty high expectations about what is going to be installed. If they don't install these, then the customer's not eligible for this. So I guess I would start with Efficiency Vermont to sort of give you some clear direction about, you know, this is what I have to start with. Get that envelope. I weatherized my house about 3 years ago. It makes a huge difference in terms of all sorts of things like durability and condensation problems and humidity issues. You know, start there, and then you can make other upgrades that make sense.
Can I just jump in and add to that? Ditto everything she said. Getting the energy audit is the right place to start. So find out. That's what I would do if I was starting right now. I'm like, oh, geez, there's water heaters, there's heat pumps, there's lawns, there's solar, there's you know, get an energy audit. And if you call Efficiency Vermont, they run this program called Home Performance with Energy Star, and you don't have to go through that program. But if you do, there's incentive money available, and yada yada yada. But the cool thing is they have a list of qualified contractors who are, we're all qualified to work in this program where you can get the incentives and stuff. But it's a great place to start in terms of like, okay, who's in the business, who's vetted, who's legit, who's doing good work out there. All the people in that Efficiency Excellence Network are all vetted. They all have reporting requirements and training requirements and certification requirements with us, and they can all.
And they've been trained on this loan. A home performance job is eligible for this. So anything that's an audit recommendation is going to be eligible for the heat saver loan. If you go and buy, you know, like 3 cases of foam and do it yourself and throw stuff in the attic, that's not going to be eligible.
Which doesn't mean you shouldn't do that.
But start with the audit if you're going to do that, because you don't want to do it without air sealing, because that's the key. Anything else?
Thank you, Laurie. I think I have email addresses.